Okay, so here we go again, exam 3. This is number 2. This is the second one. All right, let's do what we always do, heading. So M108, spring 21, exam 3, review B. Problem number 4 is where we're up to. Okay, so they give you 10 boxes, and they're supposed to represent cards. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fine. Now, a couple of them I put a little slash through. The one that has 1 in it, the one that has 5 in it, the one that has 9 in it, and the one that has 10 in it. And here's the key. If it doesn't have a slash, those are white cards. White cards. And if it has a slash, then those are gray cards. It really doesn't matter, but that's the case. That's the situation. Now, obviously, a card is drawn. Card is drawn. Take a card out. 4A, question. What's the probability that that card will be white? Answer. Let's see how many are white. 1, 2, 3, 4, 5, 6 out of 10. So the probability is 6 out of 10. And then whenever you can reduce, you must reduce. And here's the answer: 3 out of 5. Problem over. If they want it in decimal, go to your calculator. 3 divided by 5. If they want it in percent, let's say 3 divided by 5 happens to be 0.6. If they want it in percent, move it over 2 places. It'll become 60%. So you're ready for fraction. We've said this many times before. You're ready for fraction. You're ready for decimal. You're ready for percent. Okay, let's continue. Question B, 4B. What's the probability of a white being white, a white card, getting a white card, but given, here's that famous word, given that the card drawn, you already know some information, inside information about this card, that the card that was drawn's number, wait, that's a D, it's supposed to be a D, drawn's number is less than 9. That is the question, is less than 9. What's the probability of all this? That the card is white, given that the card drawn's number is less than 9. Okay, here's the answer. How many cards are less than 9? We know that the card's less than 9, right? Given. This is given. So this is inside knowledge. We know that. Insider information. We know this to be true, that the card is less than 9. So that means it's not 10, it's not 9, it's less. How many of those cards are there? There are 8. That's our denominator. That's our denominator if we've got our inside information that is less than 9. Now, how many of those 8 are white? Well, 1, 2, 3, 4, 5, 6. 6 out of 8 are white. And therefore, you reduce, you get 3 over 4. And here is the final answer in fraction form, 3 over 4. And that's it for this problem. Problem number 4 is done. Okay, now, problem number 5. Even I don't have enough room. I might have some room there, but it's still not enough. So let's get rid of this. Let's get a new piece of paper. Here we go. problem number 5. Up top there. Fine, now I got plenty of room. There are 24 students involved in this problem. 8 are math majors. Okay, 3 history majors. 13 business majors, right? 13, 3, and 8 is 24. 13 business majors. Fine. Now, there's more to this narrative here. We've got to keep following this. 2 will be selected. 2 out of these 24 will be selected. Okay, for whatever reason. Doesn't matter. The first is going to be at random. Well, they're almost always at random. But anyway, the first at random. That's how it's expressed in some of these problems. Now the second, okay, the second, of course, at random too. But there's something more here. From remaining students, those are key words. From remaining. The first student doesn't go back in. From remaining students. Okay, that's key. Now, here comes the question. That's the narrative. Here comes the, let me put a little block there. Here comes the question. What is the probability that the first is a math major? First one selected is a math major. Okay, and the second, we want this exact thing to happen. First is a math major, and the second student that is selected is a business major. Okay, that is the question. Here's some more instructions. Round your final answer. Round your final answer to 3 decimal places, right? So it would be 4 to make 3. Okay, so a lot of stuff had to be written over here for this problem. It might not be that complicated, but still we had to write a lot. Okay, here comes the answer together with scrap paper work. Scrap paper. Let's call the event let's call the events that you select a math major, right? Event A. So let's call event, let me put the event A is going to be math major. Sorry about that. I'll put math just right above it. And event B is the event that you select a business major. I'm not writing every single thing down. So let's recall event A that you select a math major, and event B that you select a business major. Right? People. We're talking about people. Okay. Now, here it is. We know as follows. If you select a math major, that is not going to impact at all whether you select a business major, right? So that will have nothing to do with it. So the probability of A and B, let me put this in writing. The event of getting the event A and B are independent of each other. right? If you select a math major, that's not going to do anything about whether you're going to select a business major or not. So they are independent of each other. Okay, so now the probability of, that means the probability of, therefore, the probability of A and B equals the probability of A times the probability of B times the probability of B. We know that formula to be true if they're independent of each other. Okay, now what was the question? The question was the probability that the first is a math major and the second is a business major. So let's take the first one. That's probability of A and B, probability of a math major and a business major. But wait, what's the chances of the first one being a math major? How many students are there when you first start selecting? 24. 24 students in all. How many are math majors? 8 out of 24. Okay, times how many when you get to the second student? That first person that you selected, does he go back in line to be selected? No, from the remaining students. The second is selected from the remaining students, so there's only 23 students left. How many of those, and what does it have to be? The second one has to be a business major. How many are business majors? 13. Right? And you didn't select the business. The first one you selected a math major. The second one is the business major. So there's 13 of those business majors left out of the 23. You multiply those two together, and what do you get? 8 over 23 is 1 over 3 times 13 over 23. Let me pull this up just in case you're not seeing this. I always have to worry about that. 1/3 times 13 over 23 is equal to 13 over 3 times 23, which is 69. Go to your calculator and you get 0.1884. I need to go 3 decimal places, so go 4 to make 3. What's the last one? It's between 0 and 4. That means you just lop it off. That means the final answer that you submit to Alex is 0.188. Those are the 3 decimal places, and the problem is finally over. Okay, we need, of course, to go to problem number 6, we need a third piece of paper. Here we go. Okay, here we go. And a third piece of paper is needed. Okay, problem number 6. Here's what you get. You get a picture that looks like this. It's got 2 balloons in it only, which makes life a little easier. 2 balloons. Okay, this is a chess club. This is a class, right? It's a class. The square is a class. The balloon on the left is the chess club, and the balloon on the right is the science club. Now, A, B, C, D, E, F, E, and F, A, B, C, D, E, and F belong to that part of the chess club. And then the people that belong to both are G, H, and I. G, H, and I. And the people that science only are J, K, L, and M. And there's one other person who doesn't belong to any, and it's in the class but doesn't belong to any of the clubs, which is N. Okay, so I ran out of time. I have no choice. I'm going to have to go to another piece. I'm going to have to end the video and do number 6 on the next video. Okay.